Solve one problem on static force analysis of 4-bar mechanism by using superposition method.
First step is to draw the diagram as per the given data. If we observe, length of these links are mentioned in the question. Fixed link AD 1000 mm is given. We have to draw fixed link. So we will consider suitable scale, and scale 1 cm is equal to 25 mm. So how to consider its a length, that is 1000 divided by 25, and which is equal to 40 cm. So we have to take 40 cm distance, and we will draw here this fixed link A to D. Now angle BAD, which is equal to 60 degree. So with the help of protractor, we have to show here, or we have to mark here one point at an angle of 60 degree. Now if I draw here one line passing through this, then that will be the link AB. So link AB is given 500 mm, and that 500 mm, that means 500 divided by 25, which is equal to 20 cm. So I will draw here one line of 20 cm. And here this angle is 60 degree, that we have to mention, and this point is the point P. Now link BC and link CD is mentioned. So BC 660 mm, that is 660 divided by 25, 26.4 cm, and CD 560 mm, that is 22.4 cm. So exact location of C is not known. So we will use here the compass. In compass, we will take the distance of 26.4 cm. We will take B as a center and mark one arc. In the same way, for the link CD, we will take here D as a center. In compass, we will take 22.4 cm distance, and we will mark here one arc. And that point of intersection is the point C. So here is the point C, and we will complete this link BC as well as link CD. Now if we move next, then on link AB, force F2 is there, and which is equal to 80 Newton at angle 73.5 degree at 325 mm from this point A. So 325 mm, that is as per our scale 325 divided by 25, which is equal to 13 cm. So we will take here distance 13 cm, mark one point, and with the help of protractor we will take here the angle of 73.5 degree. So if we observe, we will take here angle of 73.5, and at this horizontal line we will mark this line, and this is the center of the protractor. So we will join this center of the protractor and this point, which is at 73.5 degree. So we will join this, and this is the force F2. So if we have to mention here 73.5 degree, and this is the force F2. Now in the same way, on link BC, F3 144 Newton at angle of 58 degree and 297 mm from this point P. So 297 divided by 25, which is equal to 12 cm. So we will take here 12 cm distance, mark one point, and at this point we will take 58 degree angle. So at this 58 degree angle we will join this center of the protractor along the horizontal line. So if I join this, then along this horizontal line 58 degree angle, and this force is force F3. Now for the next link CD, F4 is 60 Newton at angle 42 degree and 373 mm from this point. So 373 divided by 25, which is equal to 15. So here we have to take the distance of 15 cm from this point D. So mark here one point, and at this point we will consider the angle of 42 degree. So whenever this angle is 42 degree, then along this horizontal line here is the center of protractor. So we have to join the center of the protractor, and then this is the force F4 which is at angle of 42 degree. So this mechanism is getting completed along with three forces. Because of these applied forces on the mechanism tries to displace from its original position. And to bring the system in equilibrium, torque is to be applied on this input link AB. So now we don't know what is the magnitude and direction of this applied torque T when all these three forces are acting on the mechanism. If we observe these three forces F2, F3 and F4 acting at a time. So we are going to solve this question by the principle of superposition. So how to apply this principle of superposition? So we will split this question into three subgroups. In first subgroup, we will consider force F2 only. In second subgroup, we will consider force F3 only acting on this whole mechanism, and in third subgroup, we will consider the force F4 only. And then for each time, we will calculate what is the magnitude as well as direction for this torque T. And then in final result, we will consider the net resultant torque, and that will be the answer. Take the first subgroup, consider force F2 only. Now first step is to identify the types of member. For that we will consider the link number. So for this fixed link AD, we will give here the link number 1, for AB 2, BC 3 and CD 4. Now how to identify this member AB? Now if we observe, here is the point of contact A as well as B. So through this A, F of 1 to 2 is getting applied, and through this B, F of 3 to 2 is getting applied. So I will write here the forces F of 1 to 2, comma F of 3 to 2. Then here this force F2 is getting applied, and we have to find out this torque T. So here is the torque that is to be applied on this link AB. So if we identify this link AB, then it is 3 force, 1 torque member. Now we will move next, that is the link BC. So here is the point of contact B and C. Through this point of contact B, F of 2 to 3 is getting applied. Then through this point C, F of 4 to 3. Then there is no any other force, because in this subgroup we are not going to consider this force F3 as well as F4. So this is the type of member of two forces only. So we have to take here two force only. So this is the type of member. Now we will move to the link CD. So for this link CD, if we observe through this point C, F of 3 to 4 is there, and through this point D, F of 1 to 4 is there. So this is the two force member only. So we have identified the types of link. Now we will draw the free body diagram. So how to draw the free body diagram? So we have to take the reference for this diagram, that is the 4-bar mechanism. So we have to take the same length for this link AB. We have to transfer it in the parallel direction, that is with the help of roller we can easily transfer this. Then we have to mark here the point for the force F2, that is we have to mark here, and we have to draw here the force F2. So I will mention here, this is the force F2. Then in the same way we have to transfer this link BC, that is the line parallel to this link BC, and we have to consider the same length, and for this CD also we have to take the same length and the direction, that is parallel. Now we will move for this member. So we have to first consider the easy member, that is easily we can consider the two force member only, because we know that the line of action of forces for these two force member is along the link. So we can write here or draw here the line of action of forces for BC as well as CD, because these two links are the two force members. So this is the rule, that is the equilibrium condition for the two force members. So line of action of CD is along the member only, so along this member CD. So I will draw here, this is the line of action of force. So for BC same rule is applied. So along this line there is the line of action of the force. So I will mention here force. So at this point B, which force is applied? F2 to 3. Then at this point C, which force? F4 to 3. Then at this point C, if we observe F3 to 4, because on the link CD it is F3 to 4, and through this point D, F1 to 4. So we can say that this is the line of action of F1 to 4, this is the line of action of F3 to 4, and this is the line of action of F4 to 3. Now if we observe this line of action for F4 to 3 and F3 to 4 are not in the same direction. So this rule, what is the rule? That is, these forces are equal in magnitude but opposite in direction. But these are in the direction of approximately 90 degree. So we can say that these forces is equal to 0. So we will take here F34 is equal to 0. So F43 is equal to 0, because the basic condition is not getting satisfied. And here F23 is also equal to 0. So we can say that if F23 is equal to 0, then on this link AB, F32, so this force is also equal to 0. So I will write here F32 is also equal to 0. And now how we can solve this? So it will become 2 force and 1 torque member, because this force is equal to 0. So what is this equilibrium condition for the 2 force and 1 torque member? So we know that the forces are in parallel direction. So the force passing through point A, we have to draw parallel to this force F2, because force F2 is equal to 80 Newton. So this is not equal to 0. So on this link force F2 is applied. So we have to draw the another force here that should be parallel to this F2 but passing through this link A. So I will show this. So this is the line of action of this force F12. So this is the line of action of force F12. Now what is the direction? So these two forces are parallel and opposite in direction. So I will show here the direction, that is in the downward direction. So these are the opposite to each other. So if we observe, these two forces form a couple and in anti-clockwise direction. So this force will move this side and this force will move this side. So this direction is anti-clockwise direction. So the applied torque, that should be in clockwise, that is in the opposite direction, and that should be in clockwise direction. These two forces F2 and F12 are equal in magnitude but opposite in direction. So to calculate torque, we have to find out the perpendicular distance in between these two forces. So with the help of this protractor, we will measure this perpendicular distance. These two edges are perpendicular to each other. So we will align one edge with this line and we will find out this perpendicular distance h. So what is this distance h? So h is equal to 3.6 centimeter. Now we will convert this, because this as per the scale 1 centimeter is equal to 25 millimeter. So 3.6 into 25, that is equal to 90 millimeter. So we have to refer h is equal to 90 millimeter. So this torque T is equal to this force F2 multiplied by H, that is AT multiplied by 90, which is equal to 7200 Newton millimeter. So we will convert this into Newton meter. So we will take torque T is equal to 7.2 Newton meter in clockwise direction when force F2 is applied. Now we will take the second subgroup. Consider force F3 only. So first step is to identify the types of members. Now we will take the link AB. So on this link AB, through this point A, there is force F1 to 2. Then through this point B, there is force F3 to 2. Then there is the torque that is to be applied for the equilibrium of the mechanism. So there is torque T. Now we have to consider force F3 only. So this F2 we should not consider. So what is this type of the member AB? That is 2 force and 1 torque. Now we will move to the next link, that is BC. So for this BC, if we observe through this point B, there is force F2 to 3. To this point C, there is force F4 to 3. Then we have to consider F3 force also. So we will take here the force F3. So this is the type of member, that is 3 force member. Now we will move to the next member, that is this member CD. So for this member CD, through this point C, there is force F3 to 4. Then through this point D, there is force F1 to 4. And we should not consider this force F4. So this type of member is the 2 force member. Now next step is to draw the free body diagram. So free body diagram, we will take the reference for this 4-bar mechanism. So each link we have to transfer as it is. So this time we have to consider this force F3. So we will take the same distance, that is this same from this point B, and we will transfer here this point, and we will take the parallel line to the force F3, and we will transfer this force F3. So if we take the easy member, that is easy member, in between these 3 is 2 force 1 torque, 3 force member and 2 force member. So we will first consider the 2 force member, that is link CD. So the line of action of force is along this line CD because this is the 2 force member. So we will draw here the line of action of force. Now through the point C, which force is applied? F3 to 4. So this is the line of action of force F3 to 4. And through this point D, which force is applied? F1 to 4. So this is the line of action of force F1 to 4. For this link BC, we will take the same line of action through this point C. So we will take here the parallel line for this point C, and we will draw here the same line of action of the force. So I will extend this. So this link BC is 3 force member. Now we don't know what is the direction of force. So for this link BC, which force is applied? So through this point C, F4 to 3. So this is the line of action of force F4 to 3. Now we know the direction of F3. So we will first find out which is the concurrent point. So I will extend this direction of F3, that is this F3 line, which will intersect to this line of action of F4 to 3. So this point of intersection is the concurrent point. So what is the equilibrium condition? That is the line of action of force passing through this point B should meet this concurrent point. So now we will draw the line that will passing through this point B and this point, that is concurrent point, and that will be the line of action of force passing through this point B. So we should take here so this is the line of action of force passing through point B. So we will draw this in the form of dash, because this is, we don't know what is the direction for this force. So which force is there? So through this point B on this link BC, F2 to 3. F2 to 3. So this is the line of action of force F2 to 3. Now we should draw the line parallel to this line of action of force F2 to 3, that should also passing through this point B for the link AB. So I will draw here the same line, that is the parallel, and this is the line of action of force. So for link AB, this force is F3 to 2. So F3 to 2. Now this member AB is 2 force 1 torque member. So what is the equilibrium condition? So for this 2 force 1 torque member, forces are parallel to each other. So I have to draw here through this point A one line parallel to this line of action of force F3 to 2. We don't know the magnitude as well as direction for all these forces. So how to find out the magnitude and direction? If we observe for this member BC force F3, magnitude is known as well as direction is also known. So we will consider this force F3, which is equal to 144 Newton. We will take some suitable scale, and that scale is equal to 1 centimeter is equal to 10 Newton. So we will draw here force F3 with 14.4 centimeter and the same direction. So we will transfer this direction of force F3 here, and this is the force F3, which is equal to 14.4 centimeter. So this is the head of this force F3 and this is the tail of this force F3. Now we will transfer this line of action of force F4 to 3. Now we can transfer this line either at the head or at the tail. So we will select any one. So I will select the head and I will transfer this line. So we will draw one line parallel to this, and here we have to transfer this. Then in the same way the third force is F2 to 3. So we have to transfer. So we will transfer at the tail. So we will take here one line parallel to this and we will transfer at the tail. This is the point of intersection. So if we observe, this is the line of action of force F4 to 3 and this is the line of action of F2 to 3. Now how to decide the direction as well as magnitude? Because the link BC is the 3 force member, we have to draw here force polygon and that should be closed. That means here F3, at the head of this force F3 there should be tail of the next force, that is F4 to 3, and at the next end we have to draw here one head. Now at the head of force F4 to 3 there should be tail of the next force, that is F2 to 3, and at the next end we have to draw here one head. Now we will find out what is the magnitude. So how to find out? So we will measure this F4 to 3. So what is the length of this F4 to 3? That is 3 centimeter. So as per the scale, 1 centimeter is equal to 10 Newton, F4 to 3 is 30 Newton. And for the next force F2 to 3, if we measure the scale, it is 13 centimeter and that is equal to 130 Newton. So what is the direction of F2 to 3? So So F2 to 3 is in the downward direction. So we will show here the direction. And what is the magnitude? So magnitude of F2 to 3 is equal to 130 Newton. Now for this link AB, same force, that is, but in opposite direction we have to show, because F2 to 3 and F3 to 2 are opposite in direction and having the same magnitude. So I will show here the direction that is in the upward direction. So this is the direction for the force F3 to 2, and what is the magnitude? Magnitude is same, that is 130 Newton. Now what is the equilibrium condition for the two force and one torque member? So these two forces are parallel to each other but opposite in direction. So I have to show here the direction for F1 to 2, that is in the opposite to this F3 to 2. So here is the opposite direction. Now how to decide the direction of torque? If we observe the direction for these two forces, that is in the clockwise direction. So to bring this system in equilibrium, we have to apply the torque that should be in anti-clockwise direction. So this is the direction for the torque T. Now we will decide what is the magnitude of this torque T. So we know that these two forces are parallel to each other. Now we have to find out the perpendicular distance in between them. So we will use this protractor. These two edges are perpendicular to each other. So I will align one edge with this one line of action of the force. So if I align this, then this is the perpendicular distance. So this h, if we measure with scale, then it is 10.5 centimeter. So if we know this scale is 1 centimeter is equal to 25 millimeter. So 10.5 multiplied by 25, which is equal to 262.5 millimeter. So how to find out this torque T? That is this force multiplied by perpendicular distance, that is 130 Newton multiplied by this distance 262.5 millimeter. So this answer is 34,125 Newton millimeter. So we will convert this into meter, that is 34.12 Newton meter. And what is the direction? So direction is in the anti-clockwise. Now we will move to the third subgroup. Consider force F4 only. Now we will first identify the types of member. So for this link AB, there are two forces. So which are those two forces? Force F of 1 to 2. Force F of 3 to 2. Then there is the torque T, which is to be applied for the equilibrium of the mechanism, and we have to find out. So this is of the type 2 force and 1 torque member. Now we will move to the next, that is the link BC. So for this link BC, force F to 2 to 3 and force 4 to 3. So this is 2 force member. And we will move link CD. So for this time we have to consider this force F4. So which are the forces? F3 to 4, F1 to 4, and this force F4. So this is 3 force member. Now we will draw the free body diagram. So we have to transfer all these links, that is the link AB as it is. So we have to take this line parallel to this, and we have to take the same distance or same length for the link AB. In the same way, we will transfer this link BC, and then we will transfer this link CD. So for this link CD, from this point D, we have to take this 15 centimeter, that is this distance, and at this point we will draw one line parallel to this F4. So here this link CD is also getting transferred. Now we will select 2 force member, that is the link BC. So for this 2 force member, we know that line of action of force is along this link. So line of action of force we will show here through this point C and through this point D, that is along this link BC. So at this point C, which force is there? So for this BC, force F4 to 3. So this is the line of action of force F4 to 3. Then through this point B, force transferred F2 to 3. F2 to 3. Now we will move to the next, that is the 3/4 member. So here this is the line of action of force through this point C. So here is also point C. So we will transfer the same line of action of the force. So we will draw here one parallel line and we will take this line of action of the force. Link CD is the 3/4 member. Now we know what is the direction of force F4. So we will extend this and we will get the concurrent point. So I will extend this F4 and this point of intersection is the concurrent point. Now through this point, line of action of force passing through D we have to show. So I will show with this blue marker. So what is the line of action of force? That is, we have to join this concurrent point and this D. So the third force or line of action of force should pass through this concurrent point. Now through this point C, which force is there? So for this link CD, F of 3 to 4. So this is the line of action of F of 3 to 4. Now in the same way, through this point D, there is force F of 1 to 4. So this is the line of action of force F of 1 to 4. Now we don't know what is the magnitude and what is the direction for these two forces. So how to find out? Now if we observe, we know what is the direction of this force F4 and we also know what is the magnitude. So magnitude of F4 is 60 Newton. So we will consider here suitable scale. 1 centimeter is equal to 5 Newton and we will draw here F4. So what is the length? We have to consider 60 divided by 5, that is equal to 12 centimeters. So I will take the line parallel to this F4 and I will take here 12 centimeter distance. So this is the tail and this is the head of this force F4. Now how to draw the next force? So this is the line of action of force F of 1/4. So we can draw the line parallel to this either at the head or at the tail. So I will draw here at the head this F of 1 to 4. So this is the line of action of force F of 1 to 4. So I will mention here F of 1 to 4. Now next is F of 3 to 4. So we have to transfer this F of 3 to 4 to this F4. So this is the line of action of force F of 3 to 4. So we have to mention this. Now we have to find out what is the magnitude and what is the direction for these two forces. So this is the force polygon and the rule is that it should be closed so that resultant force is equal to 0. So how to close this? So if we observe at the head of the F4, there is the next force F of 1 to 4. And at the head there should be tail of the next force, that is F of 1 to 4. So it's a head we have to show to the next end, that is here. And at the head of the F of 1 to 4 there should be tail of the next force and next force is F of 3 to 4. So we have to close this in this way. Now we will find out magnitude. So how to find out magnitude of F of 3 to 4? So for that we have to measure this length. This F of 3 to 4 is equal to 9 centimeter and 9 multiplied by 5 which is equal to 45 Newton. So this is the magnitude. And what is the direction? So if we observe F of 3 to 4 is having direction towards the left hand side. So we have to show this. So I will show here for F of 3 to 4. This is the direction that is towards the left hand side. Now in the same way we know that the force, that is the direction of force F of 1 to 4. So this is F of 1 to 4 and direction is in the downward direction. So we have to show this direction that is in the downward. Now we will move to the next force. So F of 3 to 4 and F of 4 to 3 are equal in magnitude but opposite in direction. So I will show here direction that is towards the right hand side. So we have to show these two forces opposite in direction. Now this F of 4 to 3 and F of 2 to 3 are equal in magnitude but opposite in direction. So I have to show direction in this way. Now if we observe, this is the line point B. So we have to show here the line of action through this point B parallel to this F of 2 to 3. So I will draw here one line parallel to this passing through point B. So this, which is this force? So if we observe for link AB, this force is F of 3 to 2. F of 3 to 2. Now these two forces, F of 2 to 3 and 3 to 2, are equal in magnitude but opposite in direction. So what is the direction of this force? That is towards the right hand side. So we have to show this. Now this member AB is 2 force and 1 torque member. So what is the rule for 2 force and 1 torque member? That the line of action or the forces acting on this member are parallel. So we have to show here line of action of the force passing through point A should be parallel to this F32. So I will show here, this is the parallel line. Now what is the direction? So direction should be opposite to this. So this is towards the right hand side and therefore we have to show this towards the left hand side. Now if we observe, these two forces forms a couple and that is work in clockwise direction. So if we observe, this works in clockwise direction, so we have to show torque in opposite direction for the equilibrium of the mechanism, and that should be in anti-clockwise direction. Now how to find out the magnitude of torque T? So for that we have to find out the perpendicular distance in between these two parallel lines. So we will use this protractor and we will align one edge with this one line. That is, suppose I will align this with this, then how to draw the perpendicular line? So these two edges are perpendicular to each other. So if I align this with one line, then the other edge is the perpendicular to this line. So we have to extend this line. So if I extend this line, then this will be the vertical distance, that is h. And if we measure this with scale, then h is equal to 16 centimeter. But we have drawn this diagram as per the scale 1 centimeter is equal to 25 millimeter. So 16 multiplied by 25 millimeter is the value of h. Now how to find out this torque T? So T is equal to, its magnitude is 45 Newton multiplied by 16 into 25, that is 400 millimeter. So which is equal to 18,000 Newton millimeter. Now we will convert this into Newton meter. That is 18 Newton meter and direction is anti-clockwise. Now we will decide what is the magnitude as well as direction for the resultant torque T. So from the first subgroup we will get T1 7.2 Newton meter and in clockwise direction. Then T2, that is from the second subgroup, torque 34.12 Newton meter and which is in anti-clockwise direction. From the third subgroup T3, 18 Newton meter and that is also in anti-clockwise direction. So for the clockwise direction and anti-clockwise direction we have to take the opposite signs. In this case, for anti-clockwise direction we will consider plus sign and for the clockwise direction we will consider negative sign. So minus 7.2 plus 34.12 plus 18. So answer is 44.92. So this answer is having positive signs, that is positive sign is for anti-clockwise direction. So this torque T is having anti-clockwise direction and the unit is Newton meter. So we can say that the torque to be applied to the link AB it should be in anti-clockwise direction and magnitude is equal to 44.92 Newton meter for the equilibrium of the mechanism.